Our question says, Mark is blowing up balloons for a party. Mark thinks that if he blows up the balloons to be double their current width, he will need double the amount of air. Is he correct? Justify your answer. So with all of the questions on this handout, these are not opinion questions. I'm not asking you whether you think that he's right or not. I'm asking you to figure out mathematically whether he's right or not. So you are going to test his theory by doing some math to figure it out. So as I read the question, it says he's blowing up balloons, and I should have specified what shape that is. It is a three-dimensional shape, and it is going to be a sphere. So he's blowing up sphere-shaped balloons. He thinks if he blows the balloon up to be double the current width, he would need double the amount of air. So when I talk about the amount of air, that would be on the inside of the shape, and that is volume. If I was talking about the amount of latex it makes to make the balloon, that would be the surface area. But since we're talking about what's inside, that is volume. So really the question is asking, if he blows up a balloon and then he blows up another balloon to be double the width, does that have double the volume? So I'm going to draw the bigger balloon with double the width. And we're going to see if it's double the volume. Now the problem is they didn't give us any numbers. So there are two ways we can do this. Number one, we could try to do it algebraically. Or number two, I can try to introduce some numbers on my own. And that's usually the method I like to do. So I would probably take the first balloon and pick a width. So width would be from side to side. So I'm going to say, let's have the width be 10 centimeters. So if we're blowing up a balloon to be double the width, that means that the width of this one would be 20 centimeters. And then all I need to do is calculate the two volumes and see whether or not I'm right. It doesn't matter what you pick for your so for your diameter. You could have picked, 7 or 300, and it'll still, as long as you're doing double, it really doesn't make a difference. Okay, so I'm going to try taking the original balloon and I'm going to calculate the volume. So according to my formula sheet, the volume of a sphere is 4 pi r cubed divided by 3. So volume is 4 pi r cubed divided by 3. So my radius is not 10. That's the diameter that I picked. So my radius of my balloon would be half of 10, which is 5. And while I'm at it, the radius of this one is going to be half of 20, which is 10. So you'll notice the radius is also double. Okay, so my volume is 4 pi, r is 5. Cubed means we do it 3 times. So 5 times 5 times 5, and then divided by 3. I'm going to do that in one step on my calculator. So I'm going to do 4 times, I'm using my pi button. If you don't have a pi button, please use 3.14159. And then times 5, 5, 5, and then divided by 3. And I get 523 point, now that's 5,9. The next number is an 8. So that 8 is going to push that 9 up to a 10, which is going to push that 5 up to a 6. So it's going to be 523.60. And that is centimeters and cubed because it's volume. And I rounded, so I'm going to put the dot. Okay, let's try the next one. So the one that we think is maybe double is also still 4 pi r cubed divided by 3. So I'm doing 4 times pi. This time the radius is 10, and cubed means we do it 3 times. Divided by 3. Okay, so 4 times pi times 10 times 10 times 10 divided by 3 is 4,188.79. Next number is a 0, so we're not going to round. We're just going to leave it as 79. And that is centimeters and cubed, and I rounded, so I'm going to put the dot. So I calculated the volume for the original balloon. I calculated the volume for the one that had double the width, and now I need to compare. So I have a choice. I could multiply this by 2, I could divide this one by 2, or I could divide this number by that number. So I am going to have a separate little area here where I do a comparison. If I take 523.60 and multiply that by 2, oops, I divided by 2 instead of multiplying by 2. So 523.60 times 2 is 1,047.2. Are they equal? No. So this is definitely smaller than this one here. So the actual volume is way bigger than Mark thought. So Mark thought it would just be double the amount of air. This is way more than double. Now, what if I wanted to know how many more times it actually is? What you can do is take this number, the 4,188.79, and you can divide that by 523.60. And if I do that, I get 7.9999, and then it keeps going. That would round up to approximately 8. So it takes almost 8 times the amount of air that it would if you just wanted this to be twice as big. And that has to do with the fact that when we multiply, we're multiplying it 3 times. So if this is twice as big, this is twice as big, and this is twice as big, 2 times 2 times 2 is 8. So that's why it's 8 times bigger. So it didn't ask me if it was 8 times bigger. It didn't ask me how many times bigger. It just asked whether or not Mark was right. So my final answer is sadly no. So no, Mark is wrong. But I am going to say the volume would be 8 times bigger. He would need 8 times the amount of air. So anytime you have a question where it's asking for a comparison, how much larger, how much bigger, how much is, bigger is the volume, or how much smaller is the surface area, just choose a number, right? Solve for the one, and then try doing whatever it says. If it asks you to double or half or change that dimension, change the dimension, and then calculate and see how they compare.